Okay, so today as the introduction to Lesson 2, Unit 1, Lesson 2, we're going to talk about exponential growth in technology, and I've asked Ms. Fenzel-Murgath to help explain how exponential growth is different than arithmetic growth. And being in the math department, she's going to help us understand that. Thank you, Amy.
Oh, you're welcome. My pleasure. My pleasure. Well, when we're talking about growth, and for example, if we started with 1 and then we added 1 each time, 2, 3, 4, 5, something like that, or if we started with 1 and suppose we were adding 3 each time, so we would have 4, 7. Both of those are examples of linear growth. And so if I wanted to model them with an equation, which would be helpful for me to predict future behavior, I would have a linear equation. Now, from that, once we go to growth and decay, that growth is no longer linear, but then it is exponential. For example, if I started with 1 and suppose it tripled, my next number would be 3, then 9, then 27, then 81. Okay? And the same thing can be said about decay, where if I started perhaps with 81 and we took a third of it each time, then I would have 27, 9, 3, and 1. So both of those, you see, increase very quickly or decrease very quickly. So when we go to model that behavior, that is actually exponential. And so when I go to write out the equation for that, that equation actually is going to look a little bit differently. These equations right here are actually pretty simple because they are all, right here I have a power of 3. And so my equation would just be 3 to the x minus 1 power. Now, the difference here is going to be in solving this. So here, if I have my equation and I have my model of what's going on, I can predict future behavior. So for example, if I wanted to figure out what's going to happen in 10 hours, then I could say, okay, x equals 10. And I would go to my equation and I would plug a 10 in and then evaluate it and I would have a prediction. But where we would have a problem is that suppose that we had a certain population and we were concerned about it maybe reaching, I don't know, 1,000. And we wanted to know when is that population going to reach 1,000. So if I had a model such as this model, and I wanted to know when is it going to reach 1,000, I would take my equation and I would set it equal to 1,000. Now, when I go to solve this equation, actually solving this equation is going to be tricky because I have a variable in the exponent. And so what I would do is I would rewrite this using a logarithm. And then when I rewrite it using a logarithm, my variable, my exponent can come up front. So I have x minus 1 log 3. And then actually log of 1,000 can be easily evaluated because it's a base 10. But anyway, when I'm solving, again, I can go ahead and I can either look this up or I can evaluate it using my calculator. And now I would have an estimate of how long it would take to reach a certain amount. Now, last thing I want to talk about is that when we go to graph these. So if I'm going to graph exponential growth, my growth, it gets large very, very quickly. Okay? And where we go from this is my upper limit. My upper limit here would be infinity. But if we're thinking about a population, like even of bacteria in a petri dish, that upper echelon is not going to be infinity because I can't fit an infinity amount of bacteria in that dish. So the reality of that, where that goes, is that we have where this is increasing, and all of a sudden it reaches a point where whatever it is, plants, animals, bacteria, where it's taking resources away from each other, and that population actually stops increasing and starts to reach a maximum limit, an upper limit. And that actually becomes the calculus problem. And so that's where we go from our exponential growth into our calculus. So that, in summation, is a little bit about our exponential growth and the mathematics behind what we need in order to make predictions and to understand the data.
Thank you, Ms. Fenzel. This is going to help us when we're predicting what population growth is going to do, how resource development and sustainability will happen with technology, because we can predict when we reach that limit the sustainable limit. This is very helpful. Thank you very much.
Oh, you're welcome.